You're welcome to Seremba Online School. My name is Mr. Katerega Fred. Today we are going to continue the property of waves, which is interference. In the previous lessons, we talked about reflection of waves. Then from reflection, we talked about refraction of waves, and we also talked about diffraction of waves. Then this is another property of waves, which is known as interference. Interference of waves. That is interference. Interference of waves. Interference of waves. Interference of waves is the effect which occurs when two identical waves traveling in the same direction. When two identical waves traveling in the same direction meet. Are you getting it? If you don't want to use the word meet, others use the word superimpose. Now listen. I've always been telling you, when we say that the waves are identical, instead, if you don't want to use the word identical, this means these identical waves have the same frequency. They have the same frequency. They have the same wavelength. And also they have the same amplitude. What do I mean here? You can also define the term interference of waves by just saying is the effect which occurs when two waves are of the same frequency, wavelength, and the amplitude traveling in the same direction meet, superimpose, or overlap on each other. You very well know that when waves merge or combine with each other, that is what we term as superimposition. That's the superimposition of what? Waves. Like when one wave meets another wave, we say that they have superimposed on each other, or they have met each other. So that is the definition of the word interference, for example. Now, we need to know the conditions for interference to occur. The conditions for interference. Are we there? So you can get the conditions from the definition of the term interference. For example, we have said the waves must be identical. They must have the same frequency, same wavelength, same amplitude, and if not, also they need to be moving at the same speed. Therefore, the interfering waves, this is the first condition, the interfering waves must be identical. Meaning that they must have the same speed, frequency, wavelength, and amplitude. Also, you can add on this one, they must be traveling in the same direction. Because if waves, like in the previous lesson, you remember as we are talking about stationary waves somewhere, the transverse waves as they were coming from opposite directions, then when they meet, they formed a stationary wave. Here it is not the case. Here the waves must be moving in the same direction for interference to take place. That's a condition also. The interfering waves must be traveling in the same direction. Must be traveling in the same direction. Hope you have noted that. Then we are going to see the different types of interference of waves. So we have the types of interference, So we have two types of interference of waves. Are we together? We have what we call the constructive interference. We have the constructive, that is one constructive interference. And we also have the destructive interference. We also have the destructive interference. Now, let us start with the constructive interference. Constructive interference. So you need to know what is meant by constructive interference. In constructive interference, after these two identical waves which are traveling in the same direction, after them meeting, what is the result? Okay, so take note of this. Constructive interference is the effect, or we can say is when two identical waves traveling, is when two identical waves traveling in the same direction, is when two identical waves traveling in the same direction. Now, the reason as to why I'm using the word identical, I want to save time of writing two waves having the same frequency, amplitude, and wavelength. So I summarize it in one word, identical. If you don't want, you have forgotten the word identical, then you can write all these have the same frequency, wavelength, and amplitude, traveling in the same direction, meet. Now the result is the constructive interference, meet to produce, or we can say to form whatever, a resultant, to produce a resultant wave, of a greater amplitude. So remember, in interference, it is just a matter of the waves now superimposing on each other. They combine and merge with each other. Then after superposition taking place, then what will the resultant wave look like? In this constructive interference, the resultant wave we are going to get, remember it's a combination, one wave meets with another wave, then we are going to form the resultant wave. That wave will be of a greater amplitude. You need also take note about this. You need also to take note. Others, they define constructive interference in simple terms, like this, that for example, this occurs, it can occur when, are we there? Maybe when I'm referring to transverse waves, when crest of one wave meets, when crest of one wave meets with crest of another wave, or trough of one wave, or trough of one wave, meets with trough of another wave. This one can help you understand it so easily. So we are going to see that the crest of one wave is meeting with the crest of another wave. And then, all trough of one wave meets with the trough of another wave. Then when the two meet, we are going to form the one with the greater amplitude. Okay? Remember, let me demonstrate for you here. An illustration here. This is what I'm trying to mean. So here you are seeing a crest of this, a trough of this size. I seeing it. Then plus this trough. Now when the two combine, they give me a combination of those two. So they superimpose. I seeing it. Now if the amplitude in this case from here to there is A, and the amplitude in this case from here to there is A, then notice that this is a combination of the two. Look at the amplitude, because you remember as we are starting waves, I told that the amplitude is the maximum displacement of the particle from the rest position. So this is displacement here. Now when you combine this and this is A, you will have what? 2A. What are you seeing there? Are we together? This is now the resultant trough. This is the trough of one wave. You combine with the trough of what? Another wave. This one gives us constructive interference. So the result here, you are seeing, this one is giving us constructive interference. It is giving us constructive interference. Or you can consider this case, if I get a crest of this size of one wave, this is the amplitude, then plus it is going to meet with the crest of another identical wave. I seeing it. They have met like this. So the combination of the two gives you a bigger crest. So the resultant wave will have a crest of that size. It is combining these two. Now you can see here I'm getting to what? 2A, twice the amplitude of these ones. Because I've combined this one and this one, then the single resultant wave will be having a bigger crest of that size. This is what I mean by constructive interference. That's what I say, to produce a resultant wave of a greater amplitude. So this one gives us constructive interference. Are we there? Then you may need to know this one also, the conditions for constructive interference. At first we have been talking about the conditions of interference in general, but now we need also to know the conditions necessary for constructive interference to take place. Conditions necessary for constructive interference. So don't strain yourselves. It is very easy here to have this trough meeting with this trough, and to have this crest meeting with this crest from the identical waves. That means that must take place when these waves are in the same state of disturbance. What do I mean there? That means they are supposed to be in phase. One of the conditions for constructive interference to occur, the waves must be in the same phase. The waves must be in phase. If they are out of phase, we shall not have constructive interference. Are we together? The state of disturbance must be the same. If you want a crest to overlap on another crest, or a trough to overlap on another trough. So another condition, we can get it from the definition, like the waves must be identical, must be traveling in the same direction still. The waves, the interfering waves, must be traveling in the same direction. In the same what? Direction. In the same direction. Okay, you can look for other conditions from there. Then let us go to destructive interference. Destructive interference. Are we there? Okay. Destructive interference. Now, what is in destructive interference? Okay. We need to see this effect. What will the resultant wave look like? Are you getting it? So, this is when two identical waves, I told you if you don't want to use the word identical, you say this is when two waves with the same frequency, wavelength, and the amplitude. That's what it means. Two identical waves traveling in the same direction. Traveling in the same direction, meet. Or you can use the word superimpose, meet. But what will be the result? Now when the two waves meet, what will be the result? Such that we can get what we call destructive interference. Meet to produce a resultant wave. Meet to produce a resultant wave of zero amplitude. The resultant wave will be of zero amplitude or no amplitude. Now, what do I mean there? In this case, when the two waves meet, okay, as they are traveling in the same medium and in the same direction, for us to have destructive interference, it means that these waves, the resultant, the amplitude dies out. We are not going to have amplitude there. The amplitude will be zero. Look here, take this note. This occurs, I'm referring to the transverse wave, okay, because we have been talking about the crest and the trough. This occurs when the crest of one wave meets with the trough of another wave. It is now the crest and the trough meeting. Because when the crest of one wave meets with the trough of another wave. Are we there? Are we there? Or trough of one wave meets with the crest of another. Whatever meets the other, whether it is the crest meeting a trough or it is the trough meeting a crest of another wave. Okay? That's what it means. Destructive interference. Then, a simple illustration to make you understand it better. We are going to see what makes the amplitude to become zero or the amplitude to die out. So, we have said a crest of one wave, for example, a crest of that size, are you seeing it? The amplitude in this case, we are going to take it to be a positive amplitude. Now that one is going to meet with the trough of another wave. So now it is meeting, they must be identical. These are identical waves. So the trough, let us take it to be having amplitude, but we indicate a negative to show just that the amplitude is negative in that case, but these ones are of the same size. Now when they meet, they are going to form. They are not going to form a bigger crest, they are not going to form a bigger trough, but because amplitude here is A, then when you add this negative A, the amplitude dies out and it becomes zero. So we are going to get a wave of no amplitude. When you combine this and that, the answer will be destructive interference. It will be destructive interference. Are you together there? Because the amplitude you are getting here, this is positive. When you add it to the negative, you're going to get 0 amplitude. Amplitude in this case, the resultant amplitude will be 0. Therefore, that is destructive. Before I wind up, you need also to know the conditions necessary for destructive interference to occur. One, get it from the definition here. The identicals must be traveling in the same direction. That one is okay. The interfering waves must be traveling in the same direction. That is one. Then this one also takes place, destructive interference, when the waves are out of phase. They are not in phase. The state of disturbance is different. That's why you see cresty and the trough meeting. So the waves, another condition for destructive, this is for destructive interference. The waves must